Let's talk about locus. Locus is a summary of coordinate geometry that we have to summarize all the coordinate geometry skills, straight lines, circles, interaction between straight lines and circles, and try to find a path of certain moving points. Alright, there will be some fixed items on the plane, like fixed points, fixed lines, and there usually will be a moving point. The moving point will move according to certain conditions. Alright, we want to know what is the path traced by the moving point under this condition, and that path is called the locus of the point. For a locus question, the answer is a formula. It's an equation, right? It tells us what is the shape of the path. So here on this page, I show you some examples of some common popular locus examples, and then there are some DSE past papers to go with it. So let's start from the top left corner, right? Let's start with this one. On this locus, we have two fixed points A and B. These are fixed points, right? They do not move. But there is a moving point P. The moving point is P is moving, so that the distance between PA and PB is always the same. Alright? So PA is the same as PB. It might be larger, it might be smaller, right? It can be like further away. But anyways, the distance of PA is always the same as the distance of PB. Alright? In that case, the path traced by Q will be a straight line, will be the perpendicular bisector between A and B. Alright? This is the locus of P. It's the perpendicular bisector between A and B. Right? If we join A and B together, we'll have the perpendicular bisector between A and B. That is the locus of P. That is the locus of P. In the second example at the middle, right, we have the fixed point A here. This is a fixed point A. Alright, and then we have a moving point P. P is moving so that the distance between P and A is always kept to be the same constant. Right? It's always the same. Alright, so in that case, the locus of P will be a circle with center at A. Alright, it will be a circle at center at A, so that regardless of the point P, alright, the distance is always the same. Point P can be anywhere along the circle. It is so that the distance is always the same. So happen we know K will be the radius of the circle. Right? So it will be a circle with center at A, radius is K. Alright. In the previous example, the locus of P is the perpendicular bisector of AB. Alright. Now you have to know how to describe the locus. Alright, in a way like this. Alright, so the third example at the top right corner, we have two fixed points A and B. Point P is moving so that PA is always perpendicular to PB. So this is point P is moving so that this is always a right angle. Alright, so we can invoke the converse of angles in semicircle. If this is always a right angle, then PAB is part of a semicircle. In other words, we have the locus would be the circle with AB as n points of diameter. The locus will be a circle with AB as n points of diameter. Alright. So it depends on the description, right? The description of the movement will tell you how P is moving. How P is moving will give you a diagram, and that diagram you have to describe the diagram in terms of the fixed items. Okay, so the first one is the perpendicular bisector between A and B, and that is PA equals to PB. And if the distance of PA is a constant, then it is a circle centered at A. If PA is always perpendicular to PB, then it is a circle with AB as n points of diameter. So these are fixed points. And then we may have fixed lines. For fixed line, we have distance between the point and the line. So point P is moving in the bottom left corner. Point P is moving so that the distance between PA is the same as the perpendicular distance between P and L. the distance between P and L is the distance between PA. So this is one example. Perhaps P can be like here, or perhaps P can be like here, so that the distance is always the same. Alright. In that case, the locus of P is a parabola like this. Alright. The locus of P is a parabola. Point A is called the focus. Alright, but never mind, it's not required. But it's helpful if you know that what we call the focus is at point A. Alright. Now and then there are two fixed lines at the bottom middle, right? Fixed lines L1 and L2. They are not perpendicular, but we have the distance between L1. We have point P. The distance to L1 is the same as that the distance to L2. Alright. So what would be the locus described by P? Alright. It turns out that the locus of P will be the angle bisectors. There are two angle bisectors. Alright. These two angles are bisectors, bisect the acute angle and the obtuse angle between L1 and L2. Alright, so the locus, they are the angle bisectors. You may want to prove all this with geometry. Alright, you can use congruent triangle to prove that they are angle bisectors with plane geometry. And if point P is here, the distance to the two lines, they are always the same. Okay. Alright, and finally, if L1 and L2 they are parallel like this, right? No intersection point, so there's no angle bisector. In that case, the locus of P will be the line parallel to them. Alright, so that point P will have the same distance to L1 and L2 regardless. Alright, it has the same distance to L1 and L2. So point P will be the straight line parallel to L1 and L2. L1 and L2. Alright, it's parallel to L1 and L2. Now, this is by no means a complete encyclopedia of different locus. Alright, there may be some other locus, but these are the more common examples you can refer to. Now, you see in the entire discussion, there's no calculation involved. So we call it a qualitative treatment of the locus, right? So only diagrams, no calculation. All you need to do is to describe the locus based on the given conditions, right? So it might be in MC, it might be in section B, section A2 question. You have to either to calculate the locus or to describe the locus, right? We'll leave the calculation at a later part. So let's take a look at some of the past paper questions, right? Okay, so these are the qualitative treatment, right? If you look at the answers, no calculation. You just have to tell what is the shape of the locus. So let's look. We have to read the description very carefully. So the first question 24, the top question. If P is a moving point such that the distance between P and the fixed point is equals to 5. So this is a fixed point, 20, 12, alright? And P is moving so that the distance is always 5 units, alright? Regardless of P, the distance is always 5 units. So the question is, what is the locus described by P? So now you know, if PA equals to 5, that would be this situation. That would be this situation, alright? And then we have the locus will be a circle, alright? The radius is 5, and the center is at 20, 12, alright? So the answer is A, is a circle, alright? And the middle one, we have two straight lines, L1 and L2, alright? L1 and L2, they are two straight lines. P is a moving point such that the perpendicular distance from L1 is equal to the perpendicular distance from P to L2. So that is precisely this situation, these two situations, right? The middle at the bottom and the bottom right corner. So whether it is this one or this one depends on whether L1 and L2 they are parallel. So let's take a look at this. For this one, the slope of L1, let's call it M1, right, will be minus 2 over 3. And for this one, the slope M2 will be minus 4 over 6. It is the same as M1. Alright, so we know L1 and L2, they are parallel. This is minus 4/6, right? With M1 and M2 parallel, that goes to this situation. So we know the locus of P will be the straight line between them. Alright, so we choose these as the answer. Alright, the diagram being something like this. We have L1 and L2, they are parallel lines. Alright, P is the point, so that is equal distance from L1 and L2. So it must be the line at the middle of L1 and L2. So that is in green, that is the locus of P. That is the locus of P. And the two straight lines, they are L1 and L2. Alright, they are all parallel. They are all parallel. Alright. And then finally, take a look at the bottom question. Now, once again, you see that there's a very little or no calculation involved. Let's look at the bottom question. So that we have two fixed points, right? A and B. They are 2, 0 and 1, 5. Alright. If P is a moving point, so that P is equal distance from A and B, right? This describes the movement. If PA is the same as the PB, then we know it is the perpendicular bisector of AB. Alright, the perpendicular bisector of AB. That is exactly the one on the top left corner. Okay. I just said that the list is never a complete list. The diagrams here, they're never a complete list of possible locus. So sometimes you will run into bizarre, strange locus like this one. Alright, so let's take a look at this one. We have a straight line L, right? L is 5x minus 7y minus 14, 0. P is a moving point, so that the perpendicular distance from P to L is equals to 3. Now that is different from everything we talk about. You have to think about it, from a fresh perspective. If the perpendicular distance from P to L is always 3, right? It's always 3. So what would you expect to be the locus of P, right? So it might be a straight line like this, alright? It might be a straight line. So this is one of the possible locus for P, alright? It's a straight line parallel to L. But now here is the most important part in this question. In addition to the one on top, you can have point P down here if the distance is also 3. Alright, the distance is always 3 units. So point P, there is another possibility. There's a straight line, also parallel to the red line L, but on the other side of L. So it turns out that the locus of P is not one straight line, but a pair of straight lines. It's a pair of straight lines. We are no stranger to this pair of straight lines. If you look at this situation, if L1 is not perpendicular to L2, we have the locus of P is a pair of perpendicular straight lines. Here we have locus of P is a pair of parallel straight lines. Alright. Okay, so this is the qualitative treatment of locus. In the next part, we will talk about some calculation on the quantitative treatment of locus.